Welcome to the fascinating world of analytical chemistry, a crucial branch of science that helps us understand the composition and structure of substances. In ICSE Class 10, analytical chemistry forms the foundation for many advanced topics you'll encounter later. This subject is all about identifying and quantifying the chemical components in a sample. Whether it's testing water purity, analyzing food ingredients, or checking the quality of medicines, analytical chemistry plays a vital role in our daily lives. Let's embark on this journey to explore the principles, techniques, and applications that make analytical chemistry so important in both academic and real-world settings. Analysis in chemistry refers to the process of determining the components and composition of a substance. It's like being a detective, uncovering what's inside a mixture or compound. There are two main types: qualitative analysis, which tells us what substances are present, and quantitative analysis, which tells us how much of each substance is there. In your daily life, you might have seen analysis in action when testing the quality of drinking water or checking for nutrients in food. Understanding the basics of analysis is the first step towards mastering analytical chemistry. Qualitative analysis is all about identifying what substances are present in a sample. Imagine you have a solution and you want to know if it contains iron, copper, or any other element. Through a series of chemical reactions, color changes, or precipitate formation, you can detect the presence of specific ions or compounds. This method doesn't tell you how much is present, just that it is there. In the laboratory, qualitative analysis often involves adding reagents and observing the results, which can be quite exciting and visually engaging. Quantitative analysis, on the other hand, is focused on measuring how much of a substance is present in a sample. This is crucial in industries like pharmaceuticals, where the exact amount of an ingredient can make a big difference. Methods like titration, gravimetric analysis, and instrumental techniques are commonly used. For example, in titration, a solution of known concentration is added to react with the analyte until the reaction is complete, allowing you to calculate the amount present. Quantitative analysis provides precise and reliable data, making it essential for quality control. Analytical chemistry is not just a subject in your textbook, it's a vital part of many industries and research fields. From ensuring the safety of our food and water to developing new medicines and materials, analytical chemistry is everywhere. It helps scientists and engineers make informed decisions based on accurate data. In environmental science, it's used to monitor pollution levels. In healthcare, it ensures the correct dosage of drugs. The importance of analytical chemistry cannot be overstated, as it underpins the reliability and safety of countless products and processes. To perform analytical chemistry experiments, you need the right tools. Common laboratory apparatus includes beakers, test tubes, burettes, pipettes, and flasks. Each piece of equipment has a specific purpose, whether it's measuring liquids, mixing solutions, or conducting reactions. Proper use and handling of these tools are essential for accurate results and safety in the lab. As you progress in your studies, you'll become more familiar with these instruments and their roles in various analytical techniques. Safety is paramount in any chemistry laboratory. Always wear protective gear like lab coats, gloves, and safety goggles. Be aware of the chemicals you're handling and follow proper procedures for mixing and disposing of substances. Know the location of safety equipment such as fire extinguishers, eye wash stations, and first aid kits. Accidents can happen, but with the right precautions, risks are minimized. Developing good safety habits early on will serve you well throughout your scientific journey. Solutions are a fundamental part of analytical chemistry. A solution is a homogeneous mixture of two or more substances where one is dissolved in the other. The substance being dissolved is called the solute, and the one doing the dissolving is the solvent. For example, when you dissolve salt in water, salt is the solute and water is the solvent. Understanding how solutions work is key to performing many analytical techniques, such as titration and precipitation reaction. Concentration of a solution tells us how much solute is present in a given amount of solvent. It's usually expressed in units like molarity or percentage. Accurate measurement of concentration is essential for reliable analytical results. For example, in titration, knowing the exact concentration of your solutions allows you to calculate the amount of substance in your sample. Mastering the concept of concentration will help you perform experiments with greater precision and confidence. Chemical reactions are at the heart of analytical chemistry. There are several types, including precipitation, neutralization, and redox reactions. Each type serves a different purpose in analysis. For instance, precipitation reactions help identify ions by forming insoluble compounds, while neutralization reactions are used in titrations to determine acidity or alkalinity. Understanding these reactions allows you to choose the right method for your analysis and interpret results accurately. Indicators are substances that change color in response to changes in pH or the presence of specific ions. They are essential in analytical chemistry, especially in titrations. Common indicators include litmus, phenolphthalein, and methyl orange. Each indicator works best within a certain pH range or for specific reactions. By observing the color change, you can determine the endpoint of a reaction, making indicators a valuable tool for accurate analysis. Titration is a common analytical technique used to determine the concentration of a solution. It involves adding a solution of known concentration to a solution of unknown concentration until the reaction is complete, usually indicated by a color change. Titration is widely used in laboratories to analyze acids, bases, and other substances. Mastering titration requires careful measurement and observation, but it's a powerful tool for quantitative analysis. Forming a titration involves several key steps. First, you fill a burette with the titrant, the solution of known concentration. Next, you add the analyte, the solution of unknown concentration, to a flask along with an indicator. Slowly add the titrant to the analyte while stirring, watching for a color change. The point at which the color changes is called the endpoint. By recording the volume of titrant used, you can calculate the concentration of the analyte. Practice and precision are essential for accurate results. After completing a titration, it's time to calculate the results. Use the volume of titrant added along with its concentration to determine the amount of analyte in your sample. The formula involves multiplying the concentration of the titrant by the volume used and relating it to the stoichiometry of the reaction. Accurate calculations are crucial for reliable data, so double-check your math and ensure all measurements are precise. Gravimetric analysis is another important quantitative technique in analytical chemistry. It involves measuring the mass of a substance to determine its concentration in a sample. Typically, a chemical reaction is used to convert the analyte into a solid, which is then filtered, dried, and weighed. This method is highly accurate and is often used for substances that form stable, insoluble compounds. Gravimetric analysis requires patience and attention to detail, but it yields reliable results. Instrumental methods use advanced equipment to analyze substances with high precision. Techniques like spectrophotometry, chromatography, and electrochemical analysis fall under this category. These methods can detect very small amounts of substances and provide detailed information about their structure and composition. Instrumental analysis is widely used in research, industry, and environmental monitoring, making it an essential part of modern analytical chemistry. Spectrophotometry is a technique that measures how much light a substance absorbs. By passing light through a sample and measuring the intensity before and after, you can determine the concentration of the substance. Different compounds absorb light at different wavelengths, allowing for specific identification. Spectrophotometry is widely used in chemical analysis, biology, and environmental science for its accuracy and speed. Chromatography is a powerful separation technique used to identify and quantify components in a mixture. It works by passing the mixture through a medium where different substances move at different rates, causing them to separate. There are various types such as paper chromatography and gas chromatography, each suited for different applications. Chromatography is essential in fields like forensics, food safety, and pharmaceutical. Electrochemical analysis involves measuring electrical properties, such as voltage or current, to analyze chemical substances. Techniques like potentiometry and voltammetry are commonly used. These methods are especially useful for detecting ions in solutions and monitoring chemical reactions in real time. Electrochemical analysis is widely used in environmental testing, medicine, and industry for its sensitivity and versatility. Before any analysis can begin, proper sampling and sample preparation are crucial. This involves collecting a representative portion of the material to be analyzed and preparing it in a way that ensures accurate results. Sample preparation may include dissolving, filtering, or diluting the sample. Careful handling at this stage prevents contamination and ensures that the analysis reflects the true composition of the material. Analytical chemistry, accuracy and precision are key concepts. Accuracy refers to how close your results are to the true value, while precision refers to how consistent your results are when repeated. Both are important for reliable data. Using calibrated equipment, following procedures carefully, and repeating experiments help improve accuracy and precision. Understanding these concepts will help you evaluate and improve your analytical techniques. No experiment is perfect, and errors can occur in any analysis. Errors may be systematic, caused by faulty equipment or procedures, or random due to unpredictable variations. Identifying and minimizing errors is essential for trustworthy results. Always check your equipment, follow protocols, and repeat experiments when possible. Learning to recognize and correct errors will make you a better chemist. Calibration ensures that your instruments provide accurate measurements. This process involves comparing your instrument's readings with a known standard and making adjustments as needed. Regular calibration is necessary for equipment like balances, pH meters, and spectrophotometers. Proper calibration helps maintain the reliability of your analytical results and prevents errors caused by faulty instruments. Standard solutions are solutions of known concentration used as references in analytical chemistry. They are essential for calibrating instruments, performing titrations, and validating results. Preparing standard solutions requires precise measurement and careful technique. Using these solutions ensures that your experiments are based on reliable and reproducible data, which is fundamental for scientific analysis. Analytical chemistry, standards are classified as primary or secondary. Primary standards are highly pure, stable, and have a known composition, making them ideal for preparing standard solutions. Secondary standards are solutions whose concentration is determined by comparison with a primary standard. Understanding the difference helps you choose the right standard for your experiments and ensures the accuracy of your results. Precipitation reactions are used to identify and separate ions in a solution. When two solutions are mixed, an insoluble solid called a precipitate may form. Observing the formation of a precipitate helps chemists detect the presence of specific ions. These reactions are commonly used in qualitative analysis and can also be part of gravimetric analysis for quantitative purposes. Confirmatory tests are specific reactions used to verify the presence of particular ions in a sample. For example, adding silver nitrate to a solution containing chloride ions produces a white precipitate of silver chloride. Each ion has its own set of confirmatory tests, which are essential for accurate qualitative analysis. Learning these tests helps you identify unknown substances with confidence. Solubility rules help predict whether a compound will dissolve in water or form a precipitate. These rules are based on the properties of ions and their interactions. For example, most nitrates are soluble, while most carbonates are insoluble. Knowing solubility rules allows you to anticipate the outcomes of reactions and design effective analytical procedures. Separation techniques are used to isolate specific components from mixtures. Methods like filtration, centrifugation, and distillation are commonly used in analytical chemistry. Each technique has its own advantages and is chosen based on the properties of the substances involved. Mastering separation techniques is essential for preparing samples and obtaining pure substances for analysis. Filtration is a simple yet effective method for separating solids from liquids. In analytical chemistry, it's often used after precipitation reactions to collect the solid product. The mixture is poured through a filter, which allows the liquid to pass while retaining the solid. Filtration is essential for preparing samples for further analysis and ensuring accurate results. Centrifugation is a technique that uses rapid spinning to separate components based on their density. In analytical chemistry, it's used to separate fine particles or precipitates from liquids. The sample is placed in a centrifuge, and as it spins, denser particles move outward and form a pellet while the liquid remains above. Centrifugation is especially useful for small or delicate samples. Distillation is a process used to separate liquids based on their boiling points. In analytical chemistry, it's often used to purify solvents or separate components of a mixture. The liquid is heated until it boils, and the vapor is collected and condensed back into a liquid. Distillation is a valuable technique for obtaining pure substances and preparing samples for analysis. Cations are positively charged ions, and their identification is a key part of qualitative analysis. Common cations include sodium, potassium, calcium, and iron. Each cation has specific tests that produce characteristic colors or precipitates. Learning these tests helps you identify unknown samples and understand the chemical behavior of different elements. Anions are negatively charged ions, and their identification is just as important as cations. Common anions include chloride, sulfate, nitrate, and carbonate. Each has unique confirmatory tests, often involving the formation of precipitates or color changes. Mastering these tests allows you to analyze complex mixtures and identify the presence of specific anions with confidence. Flame tests are a quick and simple way to identify metal ions based on the color they produce when heated in a flame. For example, sodium gives a yellow flame, while copper gives a green or blue flame. Flame tests are especially useful for detecting alkali and alkaline earth metals. This technique is widely used in both educational and professional laboratories. Analytical chemistry isn't just for the lab, it has many applications in daily life. From testing the purity of drinking water to checking the nutritional content of food, analytical techniques help ensure our safety and well-being. They are also used in environmental monitoring, forensic investigations, and quality control in manufacturing. Understanding these applications shows how analytical chemistry impacts our everyday experiences. Environmental analysis uses analytical chemistry to monitor pollution and assess the quality of air, water, and soil. Techniques like spectrophotometry and chromatography help detect harmful substances at very low concentrations. This information is vital for protecting public health and the environment. Analytical chemistry provides the tools needed to address environmental challenges and promote sustainability. Analytical chemistry plays a crucial role in ensuring the safety and quality of food and medicines. Techniques like chromatography and spectrophotometry are used to detect contaminants, verify ingredients, and measure nutrient levels. Regulatory agencies rely on analytical data to set safety standards and protect consumers. This field helps maintain public trust in the products we use every day. Forensic analysis uses analytical chemistry to solve crimes and investigate incidents. Techniques like chromatography, spectrophotometry, and DNA analysis help identify substances found at crime scenes. Analytical data can link suspects to evidence, determine causes of death, and uncover hidden details. Forensic chemistry is a fascinating field that combines science with detective work. Industries rely on analytical chemistry for quality control, product development, and regulatory compliance. Analytical techniques ensure that raw materials meet specifications and finished products are safe and effective. From pharmaceuticals to manufacturing, analytical chemistry supports innovation and maintains high standards. Understanding its industrial applications highlights the importance of analytical skills in the workforce. Background in analytical chemistry opens doors to many exciting careers. You could work in research, environmental monitoring, pharmaceuticals, food safety, or forensic science. Analytical chemists are in demand for their ability to solve problems and ensure the quality of products and processes. Developing strong analytical skills can lead to a rewarding and impactful career in science. Analytical chemistry is a dynamic field, with new techniques and technologies emerging all the time. Advances in instrumentation, automation, and data analysis have made it possible to detect substances at lower concentrations and with greater accuracy. Staying updated with these developments helps scientists tackle new challenges and expand the possibilities of chemical analysis. Despite its many successes, analytical chemistry faces challenges such as detecting trace amounts of substances, dealing with complex mixtures, and ensuring data reliability. Scientists are constantly developing new methods to overcome these obstacles. Understanding these challenges helps you appreciate the skill and creativity involved in analytical work. Ethics play a vital role in analytical chemistry. Scientists must report data honestly, avoid falsifying results, and respect safety and environmental regulations. Ethical practices ensure that analytical results are trustworthy and that science benefits society as a whole. Developing a strong ethical foundation is as important as mastering technical skills. Analytical chemistry is a cornerstone of scientific discovery and practical application. From understanding the basics of analysis to mastering advanced techniques, this field offers endless opportunities for learning and growth. Whether you pursue a career in science or simply want to appreciate the role of chemistry in everyday life, the knowledge you gain from analytical chemistry will serve you well. Keep exploring, stay curious, and remember that every experiment brings you one step closer to understanding the world around you.